So in this video, I'm going to perform the integral of this particular function with respect to x, and it's going to be between the bounds of 1 and 1.3. Now, because this equation is all written in terms of x, it implies that these bounds are also in terms of x. So if I wanted to, I could kind of make that quite explicit by writing x equals 1 and x equals 3 out the front. Alright, so I'm going to try and use integration by substitution in order to perform the integral of this function. So what we're looking for integration by substitution is an inner function. And when we take the derivative of that inner function, we want the derivative to appear in some form elsewhere in the equation so that we end up with some cancelling going on. So I would suggest in this case, the inner function we want to select is what's inside the brackets here. So I'm going to call u my inner function, and therefore it's going to be equal to x cubed plus 1. Now if I take the derivative of this, it's going to go to 3x squared, and the derivative of 1 goes to 0. So that's the complete version. Now I can see that this looks quite similar to something else in the equation, which is good. So now I should just rearrange to get dx on its own and substitute it in up here, and hopefully we'll see some cancelling. So if I bring the 3x squared down to the bottom line on the other side of the equation and multiply the dx up to the other side. So now let's go back and replace it up here. So we're integrating from x equals 1 to x equals 1.3 of this particular function, and we're replacing, so it becomes du on 3x squared. So now I see I have this x squared and this x squared, they're on top and bottom lines, so they should end up cancelling out with each other. So now if I clean this up a little, I've got this 3 on the bottom line, so to make life easier, what I'm going to do is bring it out the front. It's just like a constant or a scalar, so we could write it as just 1 on 3. And we have all of this still integrated now with respect to du. Now at the moment all of this stuff is written in terms of x, but really we need to write it in terms of u since we've swapped this over. So let's think about the bounds first. All right, they're written in terms of x, but we have a relationship between x and u. So what I should be able to do is just figure out if x is equal to 1, what does that make u equal to? So let's substitute it in. So we get u equals 1 cubed plus 1, and that's going to end up being 2. And if we do 1.3 now, substituting it in, u is equal to 1.3 cubed plus 1. This works out to 3.197. So now I should be able to come down here and rewrite my integral. So the third stays, all right, u is equal to 1 is equivalent to, x is equal to 1 is equivalent to u is equal to 2. So let's pop that here. And x is equal to 1.3 is equivalent to u is equal to 3.197. All right, next we have this bit written in terms of x, but we should be able to swap it over to u using this expression as well. So x cubed plus 1 is equal to u, so it becomes u to the power of 10. And we're doing all of this because we've written our thing so that we need to integrate with respect to u. So now we should be able to actually do the integral. So we've got this third constant out the front, all right, but now we can do the integral of x to the power of 10, u to the power of 10. So if we add 1 to the power, that goes to 11, and divide by the new power, which is 11, and we want to carry across our bounds. So u is 2, u is 3.197. So now it's just a case of actually doing the substitution of our bounds. So we've got this third, which needs to be multiplied by everything. And if we put in the upper bound first, we get 3.197 to the power of 11 on 11. Minus, we put in our lower bound, so 2 to the power of 11 on 11. So if you pop all of this into a calculator, you end up with the answer of 10,744 approximately. So what that represents is the area under the curve for our function x squared x cubed plus 1 to the power of 10 between x is 1 and x is 1.3. So that's all there is in terms of this video.